Let's continue with the next 10 questions of the NMOS. If you haven't seen the previous video with the intro and questions 1 to 10, feel free to switch back to it after you've looked at this video as well. Okay, so question 11, we're given a straight line. BE and CE intersect at point E, and you're given some equal angles, which is pretty important, otherwise we have no hope of solving this question. So ABE equals to EBC, ACE equals to ECF, and we are supposed to find angle BEC. Okay, so the first thing that you should realize is that you won't be able to find any of the angles that immediately, but we have to use the 68 degrees in possibly more than one way if we are going to solve this. Now, the first thing that I would see is to look at triangle ABC. If you look at triangle ABC, (68 degrees is one of them, but it is also related to the other two angles. So using our exterior angle property, we know that ACF equals to 68 degrees plus ABC. So I think I should give these some names. I'll just call this one 1 unit and 1 part. I think we are comfortable with this. So now it means that 68 degrees is actually equal to this exterior angle, 2 parts, minus 2 units. Now let's look at this angle over here. And to look at this angle over here, I will draw another triangle. The other triangle that I will draw is over here, BEC. Now if you look at BEC, you realize that this angle we're supposed to find can also be seen as part of the exterior angle relation, which is 1 part minus 1 unit, ECF minus EBC. So from here, it is pretty obvious that this question mark is just half of that. So 68 divided by 2 equals to 34 degrees. Now notice that we didn't actually go and calculate what's 1 part and 1 unit, but there's no need for that. Let's move on to question 12. What's the average of all 4-digit numbers that can be formed by using the digits 2, 3, 5, 6 exactly once? There is a way to solve all these kinds of questions in general, but for this particular choice, it is pretty nice that they gave you 2, 3, 5 and 6, because there's a bit of symmetry going on. You realize that 2 plus 6 and 3 plus 5 both give you 4. So both give you 8, which is an average of 4. So for example, if let's say that you have 2, 3, 5, 6, I can pair it up with 6, 5, 3, 2. Now, because the digits 2 and 6 sum to 8 and 3 and 5 sum to 8, it gives you a sum of 8, 8, 8, 8, and the average is 4, 4, 4, 4. Now if I took, let's say, another combination like 5, 6, 2, 3, 2, this can also be paired up with 5 becomes 3, 6 becomes 2, 5 and 3 are paired up, 2 and 6 are paired up, so you get this so-called companion that again will give you the same average of 4, 4, 4, 4 and the sum of 8, 8, 8, 8. Now the importance of this is that among all your 4-digit numbers, you can always pair them up into 2 numbers that sum to 8, 8, 8, 8, 2 numbers that sum to 8, 8, 8, 8, and so therefore the average of the whole thing will be just 4, 4, 4, 4 in the end. Okay, question 13. Abel's father drives him from their home to school in 30 minutes, but his mother can drive him 24 km/h faster and gets him to school 8 minutes earlier. What's the distance between Abel's school and his home? Okay, 30 minutes and 8 minutes earlier, so this is 22 minutes. 30 minutes versus 22 minutes is something that gives you the ratio of the speeds. Right, so I'll just use F for father and M for mother. In terms of time, the ratio is 30 minutes to 22 minutes, which is 15:11. Now we know that the faster you go, the less time you need. So which means that if you take more time, you are slower. So the speed would be flipped around into 11:15. So 11 and 15, let's just call this 11 units and 15 units. The difference between 11 and 15 is 4. So the difference between them would be 4 units, which corresponds to 24 km per hour. So that means that 1 unit is 6. And 11 units would be 66 km per hour. So 66 km per hour for half an hour using the father's 30-minute timing tells us that the distance would be half of 66, which is 33 kilometers. Which is really a long way to be in Singapore. I'm not sure how many people in Singapore are 33 kilometers away from their school, right? That must mean that you stay somewhere in Loyang and you're going to Jurong to school, which is a little bit of an odd choice. But yeah, this is for the purpose of the question only. Question 14. The clock below shows 3:34 p.m. Find the angle between the hour and minute hand. This is a classic question. If you haven't seen it before, do try to learn the method here. Now, how I like to do it is to think of it as starting from the hour, which could be in this case 3 p.m. Now think of it as the initial position on a circle, count the top as 0 degrees, and then let's say if it's 3 p.m. that was 90 degrees. Now in 34 minutes I just want to know how far they have moved, and once I know how far they have moved I will be able to get the required info. For your minute hand, the minute hand will always move at 6 degrees per minute, because in 1 hour, 60 minutes, it goes 360 degrees. So in 1 minute, it goes 6 degrees per minute. So 6 times 34. Okay, my software is lagging a little bit, so give me a second to clean up my handwriting a little bit. So 6 times 34, and as I'm sorting this out, you can think about how the hour hand would work. So 6 times 34 would be 204 degrees. So that's the position, not the final answer. I'll just mark it here as 204. Now your hour hand, in 1 hour, it goes 30 degrees. So 60 minutes, it goes 30 degrees. That means that your hour hand is 0.5 degrees per minute. So in 34 minutes, it will go half of 34, which is 17 degrees. So 17 degrees plus to the 90 is 107 degrees. So that's the position that is at on this circle. If you want to find the angle between them, you basically just subtract these two from one another. So 204 minus 107 is 97 degrees. Now there's nothing special about 3:34 p.m. so you could have done the same method for any other time and found the angle just as easily. Question 15. The sum of two different prime numbers is 90. Their product is a 4-digit number. Find the largest possible value of this product. Well, we know that when you're trying to find the largest possible product, which is meaning multiplication, and they tell you that the sum is fixed, we want to make the two numbers as close together as possible in order to make the product as big as possible. So two close numbers should do the trick. Now they have one additional thing, actually two additional things if you like, that we have to remember. it says that they are different, and it says that they are prime numbers. So that means that you cannot just repeat 45 and 45, and you also cannot do 44 and 46, right? So 45, 45 doesn't work because they said different. 44 and 46, the next closest, doesn't work because they said prime. 43 and 47, however, does work because 43 and 47 can be verified to be prime numbers. Remember that prime numbers are numbers that only have 1 and themselves as a factor. So that means that for you to check 43, you just make sure that, okay, it's not divisible by 2, not divisible by 3, not divisible by 5. So it is definitely a prime number. And so you definitely can say this must be the best because that's the closest they can be. One more reason why you know this must be correct is if you multiply 43 times 47, you would find it to be 2021, which is the year number. And it is a very common tradition in math Olympiads to try to sneak the year number in as many places as we can. So when you see 2021, you're probably correct. Question 16. Joel participated in a math contest which comprises 2 sections. In section A, each question is worth 3 marks. In section B, each is worth 5 marks. It's known that Joel answered 8 more questions correctly in section A than in section B, and his total score is 80 marks. There is no demerit for incorrect or blank answers. Okay, so we can think of it this way. If we want to find out how many questions that he got correct, we can think of it as 8 more questions in A than in B means that there are basically 8 times of A, which is worth 3 marks, and then there are some number of A and B. You can think of it as once you take away this 8, it's equal. So A and B kind of come in pairs. Okay, so 8 of the questions in section A are worth 8 times 3, which is 24 marks. So 80 minus 24 means there are 56 marks left that he got from these pairs. Now 3 plus 5 is 8, and so 56 divided by 8 should be 7. That means there were 7 pairs of questions A and B that he managed to get. And so if we are asked how many he got correct, it would be 8 plus 7 pairs, which is 22 questions. Yeah, I think you can solve this using model drawing as well, but remember for the NMOS, one key consideration is how quickly you can solve the question. So if you can do it without having to draw a model and assuming that you can do it faster without the model, then you should try to avoid it because this would save you a lot of time. Question 17. A boat travels 120 km downstream along a river in 6 hours at a constant speed and takes 10 hours to return upstream to the starting point at another constant speed. Find the speed of the boat in still water. Okay, this one here, this sort of question, may be a little bit harder for us as Singaporeans because we don't see boats in a very long river very often. It is not a common thing to see. So think of it as the boat traveling downstream and upstream. It means that there are 2 different speeds at play, right? There is actually the so-called pure boat speed, and then there is the current speed, right? The current of the water in the river. And what the 2 statements in the question are telling you are how the boat speed and the current speed are combining together. So 120 km downstream in 6 hours means that downstream is with the help of the current. So the boat and the current combined together gave you 120 km in 6 hours, which is 20 km per hour. Now, it takes 10 hours to go upstream means going with the current opposing the boat. So whatever the boat's so-called true speed is, the current is opposing it by pushing you back. So you only travel at 120 divided by 10, which is 12 km per hour. Now it means that from the boat, you plus something, you get 20, you minus something, you get 12. So that means that the true speed should be at average in the middle. Right? So it means that the average is 16. So the boat's real speed is 16. Oh, that looks horrible. Let me write that again because that's actually the final answer. Right? The actual boat speed is 16 and the current is 4 km per hour, just for completeness sake. Okay, this is not a very difficult question, but just take note, sometimes they may ask you in a different way. It might say, what is the speed for, let's say, an object to float along the water? If they ask you that, it is basically asking you for the current speed, because if an object is floating, it moves at the speed of the current. Right, so take note of what the question is asking. Here they're asking you for the boat if there were no current, is what you're supposed to find. Question 18. These kinds of puzzles is a very tricky thing to say whether you should do it or not. Now, if you're very comfortable for these kinds of puzzles, you can solve them very fast. If you tend to be very lost about it, you should skip it first, because maybe you find it fun, but if it takes you 15 minutes, there's no fun at all, because you should have skipped the question and you could have solved 2 or 3 others in that time. Okay, so this puzzle here has been truncated, so you only see the corner of it. So you only know that, let's say, one across is 3 digits, 1 down is 4 digits, 2 down is 3 digits, and you can't see anything else. But they gave you some clues here on the across and downs that we can see. So there are 4 clues. One across is the square of 8 down. So it's saying that this is a square number. Across. It's saying that this is a square number. Just writing over the question here. Secondly, 6 across is half of it. I don't think we can say much of it, but I'll just say that since it is half of it, it tells you that the 1 across must be even. Maybe I should write it like that, right? So square and even. For you to have half of something, it must be an even number. Now, 1 down is twice of 2 down. Okay, so that's another even number. And 2 down is a multiple of 9. Now, if 2 down is a multiple of 9, and then 1 down is twice of 2 down, that means that it is also going to be a multiple of 9. Okay, but this doesn't seem to be quite enough information, because if this is a multiple of 9, this is an even multiple of 9, and then there's just some even square number here, what am I supposed to do? Okay, so there is one thing that may not stand out as a clue, but is implicitly in the question, which is that 1 down is a 4-digit number, while 2 down is a 3-digit number. So the 3-digit number multiplied by 2 becomes a 4-digit number. Well, no matter how big your 3-digit number is, you multiply by 2, it must be less than 2,000. So it must be 1,000 and something. Okay, so that's the first thing. Now, because it's 1,000 and something, I can now look at this 1 across, which is an even square number that is 3 digits and starts with 1. So let's write down, 10 squared is 100. We can't use 100 because then this will start with 0, which we cannot start with a 0, otherwise that will not be a 3-digit number at all. Now it has to be even, so I will jump 11 and I'll go to 12 squared is 144. Now we might want to try this, but we realize that no, this doesn't work either, because 400 and something, if you have twice of it, it's still going to be at most 900 and something. It cannot reach 1,000. So that will not give you a 4-digit number for 1 down. So that also doesn't work. So we jump ahead. 13 is odd again, so we go to 14. And 14 squared is 196. Now this is kind of our last shot, because we are already going to go past 200, so it better work. And so it should be 196. That's kind of your only chance. And then you see that 6 across is half of 1 across. So I can fill that in as well. This is 98. And then looking back at this, a multiple of 9. 6, 9 something is a multiple of 9. Using the divisibility test for 9, we know that the sum of digits must be a multiple of 9. So 6 plus 9 is 15. The only way to get a multiple of 9 is to have a 3 down here. So you get 693 as your answer. We can fill up this times 2 as 1386, but remember this is not needed, so actually you shouldn't do that in the competition. Okay, so quite a few small little deductions here. It's not an easy question, but I think it's a fairly fun question to think about, perhaps after the competition. Okay, question 19. Each of the boxes below contains either a plus or minus sign. Find the number of ways that you can allocate the plus and minuses so that this is valid. Now, this is a really interesting question. Now, the first thing to know is that thankfully they didn't say multiplication and division. Otherwise, we will have to deal with order of operations, and that will be really annoying. Right? Addition and subtraction, at least you have a bit less headache. Right? It just means that, okay, you just add and subtract from left to right. Now, we should also figure out, is there anything interesting about 16? Right? And so I'll just try, let's say that I plus everywhere. Okay, so the sum of everything from 1 to 8, if you add it carefully, you would see that it is actually 36. Now, 36 is much bigger than 16. But actually, it is not as far away as we might think. Because when you switch, let's say, from a plus to a minus, now let's say that I switch from plus 8 to minus 8. Now, you don't just reduce by 8. When you switch from plus 8 to minus 8, it means you have done two things. You are no longer adding, and you are now subtracting. Right? So if you change the plus 8 to the minus 8, you actually reduce by 2 times 8, which is 16. Right? You're not reducing by 8, you're reducing by 16. So 1 plus 2 plus 3 all the way to 7, and then you minus 8, this is already 20. So it has dropped a lot. Which means that from 36 to 16, you reduce it by 20. But every time when you change a plus to a minus, the amount of drop off is 2 times of whatever you select. So 20, you can further divide it by 2 to give you 10. And so 10 would be the sum of the numbers which we subtract. And by the we subtract, it means that if you put a minus sign in front of it, then of course we subtract it. Okay, so the whole question now becomes something a lot easier. We just need to ask, how many ways are there to pick numbers that sum to 10? Right, this sounds like something you probably have done before in a bunch of activities learning about addition. So let's do it first as if I have two numbers that sum to 10. It can be 2 and 8, 3 and 7, or 4 and 6. It cannot be 5 and 5 because you cannot subtract 5 twice. Additionally, you can also have 3 numbers. Now you realize that 1 is at the front, right? So you cannot say, I start with minus 1. No such thing, right? Because there's no box there. So any combination you want, you must start with 2. So 2 plus 3 plus 4, if you have 3 numbers, is already 9. So if you want to get to 10, the only other way is if you do 2 plus 3 plus 5. Okay, let me clarify that when I say 2 plus 3 plus 5, it means that 2, 3 and 5 are the numbers that we subtract. So if let's say that you write it as this, minus 2, minus 3 and minus 5, this would be one acceptable way that you could get to exactly 16. Okay, I'll leave you to check out why that works. Check out that it really works, but you have seen why it works. So there are only 4 combinations here, so the answer is 4 ways. Okay, finally, question 20. At a party, each person shakes hands with every other person exactly once. Given that there are 300 handshakes at the party, how many people are there at the party? This handshaking one, another classic question. Now there are 2 different ways that you can get to the same conclusion about how many handshakes there are at the party. Now, let's just say that I'll pick a random number like 10 people at a party. Now, there are two different ways that you can count the number of handshakes. The first way is to look at the people one by one. So I imagine that the persons are just numbered person 1, person 2, person 3 until person 10. I say, okay, person 1, go and shake hands with everybody. So person 1 goes and shakes hands with 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would give you 9 handshakes. Then you go to person 2 and say, now go and shake hands with everyone except person 1, because you have already had the handshake with him. So then that would be plus 8. Now we go to person 3 and say, okay, shake hands with everyone except person 1 and 2, because they have already came to shake hands with you. So now there's 1 less again, so it is plus 7, and then plus 6 all the way down until person 9 just goes to shake hands with person 10. Person 10 says, oh, everyone came to me, so I don't need to shake hands with anybody. So this is one way that you can count the number of handshakes. You just start from the number, and then you minus 1, minus 1, minus 1 each time, and then you add up the results. Okay, just for the record, this would be equal to 45. Now, the other way would be to think of it in terms of a big picture perspective. Think of it as you go and ask the people after the party, so how many people's hands did you shake? So if there are 10 people, everyone said, hey, I shook 9 hands, right? Because they shook hands with everyone else. So you can say that person 1 says, I shook 9 hands. Person 2 says, I shook 9 hands. So there will be 9 times 10. But that's not 45, right? That is 90. That's twice of 45. So the reason why it is twice is that every handshake should be counted once, but you counted it twice, because if let's say you have a handshake, the first person counted it in his 9, the second person also counted it in his 9. So in your 90, you counted that handshake 2 times. So we need to divide by 2 to get the same result. Now that you understand this, the idea is you have to do one of the following, right? So you either, if let's say you want to have 300 handshakes, and suppose there are n people, either you can say that 1 plus 2 plus 3 plus 4 all the way until n minus 1 should be 300. And then you figure out what's n, maybe by a bit of guess and check. Or you can say that n times n minus 1 divided by 2 is equal to 300, using the second method. Now I think the second one is a bit easier when the question is asked like this, because it is in this reverse order. You can just say something times that thing minus 1 divided by 2 is 300. It means that the number times itself minus 1 equals to 600. And you can do a little bit of guesstimation here, right? Because you know that if n is 10 or 20, that's too small. If n is 30, that's too big. So it should be 20 something, and 20 something in a way that the last digit is 0. Right? So if you adjust a little bit, you would realize that your answer is n is 25. So there are 25 people, and 25 times 24 is equal to 600. Okay, so this is the end of the second part of the video. In the third and final part, we will look through questions 21 to 30. So take note that this video is slightly under 30 minutes. Remember that I said that you should take about 30 minutes for the middle section and 40 minutes for the last section. So I hope from here you can see that it is doable, because I have explained some of the big ideas that you wouldn't actually need to go into when you're solving the question. So 30 minutes is attainable, even though it is a little difficult, it still can be done. Okay, so I'll end this video here, and when you're ready, you can check out the last part of the video.